Hello everyone, and welcome back to my channel. At first I was a little bit reluctant on doing this tutorial because YouTube and internet in general is full of electronics tutorial of all sorts of topics. But I figured, what the hell, one more tutorial cannot be bad. And since I kind of want to have this channel more or less a one-to-one mirror of my other Romanian channel, I thought to actually have this tutorial done, because who knows, maybe if somebody manages to land on my channel instead of another one and manages to find this information useful, so yeah, why not? So in this tutorial I will talk very briefly about what options do we have when we are beginners in electronics. We don't really have equipment, we don't really have a lab, not even in the smallest sense of the word. Maybe right now we are building one, and we need to play with a few circuits now and then, and we obviously need to power them somehow. Now, normally you would need to have a power supply, a lab power supply, which gives you possibility to adjust voltages and maximum currents and stuff like that, you know. But like I said, maybe we are at the beginning of the road and we don't really have much, so we need to handle ourselves with whatever we can. So I will briefly explain a few options that we have as beginners and what are the advantages and disadvantages. So one option is to use batteries or rechargeable batteries. I mean, yeah, it sounds a bit silly at the beginning, but if you think about it, sometimes you have low voltage, low power circuits that you need to power with some electricity. And it's not a real problem to have some 9-volt batteries and some 1.5 volt batteries or 1.2 volt rechargeable batteries, and have them power your circuit. It's not completely impossible. Again, if the circuit is drawing a very small current, like milliamps or tens of milliamps, batteries are capable of delivering this. So the cheapest option is to buy batteries or rechargeable batteries and a recharger. Buy these kinds of plastic cases with contacts that allow you to place batteries inside and gives you a few wires on the outside so you can connect them. They come for both AA batteries and 9-volt batteries, perhaps even other kinds of batteries like AAA batteries or so. And it's not impossible to use them, place batteries inside, connect them in parallel, in series, however you need, and use them. It's the cheapest, absolutely cheapest option that you can possibly have. And again, it works for some circuits without a big problem. The second option we have is to use a computer power supply. Now, again, this option has been shown and discussed by tens or possibly even hundreds of other YouTubers so far. It's not new, it's not anything special, but I will quickly show you how it's done. You can use a computer power supply, even a cheap one, it doesn't really matter which one. A computer power supply gives a 12 volt, a 5 volt and a 3.3 volt outputs at pretty nice currents. This one here says it has theoretically 450 watts. And it says that it gives me 20 amps at 3.3, 32 amps at 5 volts, and two rails of 12 volts each, one with 10 and one with 15 amps. Now, of course, being a very cheap one, I don't suspect it actually gives that much current, but this is quite a large current to have, and for most circuits that an amateur works with, it's more than enough. Even if this one gives only half of this current, it's more than enough, so not a problem. So to quickly show you how to turn on such a power supply, you take the ATX 20 or 24 pin connector, which normally goes to the motherboard. You look at it and you identify the green wire. There's only one green wire, there aren't several, right? You identify the green wire and you take something like a cable, a wire or anything. I just used a paper clip that I unfolded, and you short circuit the green wire to any black wires. The black wire, all black wires are the ground basically, and you just need to short circuit the ground with the green wire. I will use a very nearby black wire, paper clip inside so it holds. And voila, the power supply is on now. The fan has started to work. I'm not sure if you're going to hear this in the video. I might actually do some noise reduction so that the noise of the air flowing is not so it's not bothering us. Anyhow, to show you what are the cables and what voltages do they give, I'm gonna connect a multimeter. I'm going to just clamp this to this paper clip because this paper clip is essentially connected to the ground, so I don't have to hold two wires with one hand. And the idea is as follows: all red wires give 5 volts, all yellow wires, let me see if I can, okay, all yellow wires give 12 volts, all orange wires give 3.3 volts, and there's a blue wire here. Not sure if you're gonna see this, but anyway, you should look on your power supply, you will see a blue wire. This one gives, well, should give minus 12 volts. In my case it gives minus 11 volts. Now for this minus 12 volts, my power supply says it can give half an amp, so not a lot of current. But if you have a small electronic circuit that needs a differential power supply, you can use this wire as well. Okay, so third option that we have, it's somewhat similar to using a power supply, computer power supply. However, we're not gonna use a computer power supply. If in the past you've had various devices that were partially broken and you didn't want them anymore, or maybe somebody gave those devices to you because they didn't want them anymore, and those devices were not completely burned out, they were not completely broken, there's a chance that you can actually salvage the power supplies in those particular devices. The majority of devices will have a PCB, a circuit board that is only the power supply, and another circuit board or many other circuit boards that are having other functions, the functions of that device itself. So in that case, you can easily salvage the power supply because you can just remove it from the device. There are also devices that have the power supply embedded onto the main circuit board with the other components, with the rest of the device. In that case, yeah, you will most likely not be able to use those power supplies. But those are exceptions. As far as I've seen, those are exceptions from the rule. Those are not the general rule. The general rule is that the power supply inside the larger device is separate from the rest of the circuits. So here I have 4 examples of power supplies I have salvaged. In no particular order, this is a power supply that was found in a very old printer. I guess you can easily tell by its size. It's relatively large, uses large capacitors. large transistor. Even though it's a switch mode power supply, it's not a linear one, but pretty much everything here is large. But it works, you know. It also came with a power connector and power switch embedded onto this board, which is nice because I can just plug in a cable. It gives me 5 and 34 volts. 34 volts is a bit high, but it's not that high. It's not impossible to work with, especially if we are designing a small circuit from the ground. I mean, from zero, from the ground up. Many components actually can withstand 34 volts without a big problem, you know. Even a small power transistor such as BC547 or 557, they can resist 45 volts or so. So this is one example. Another example also from a printer, but this time a more modern printer, an inkjet A3 multifunction that also had a scanner, gave me this power supply, 220 volts here. I measured it. I don't remember exactly if only one voltage is given or multiple, but the largest one is 30 volts. So it can be definitely used in some applications. If we don't have a proper power supply, we can just power our circuits with something like this. Another power supply that came from another device, this one I really don't remember what kind of device it was, but it's even smaller than this other one. I measured it, it gives 12 volts, only 12 volts, and a maximum of 3.5 amps. 230 volts here, 12 volts here. In case you're wondering how exactly do I know that it gives 3.5 amps, well, I used an artificial load, or so-called DC electronic load. It's a device that allows you to perform various tests. It allows you to draw currents from power supplies and batteries and so. I have actually made such a device earlier, and there's a tutorial on this channel. You can just go find it, and it's a rudimentary artificial load, but it's useful, and it's definitely useful enough to allow you to determine what's the maximum current that a power supply can give, especially when you're salvaging one from a device and you have just no idea what's the maximum current that you can get from it. The fourth and last example I can give you when it comes to power supplies that I have managed to salvage from various devices is this. Perhaps some of you recognize this. This is a PlayStation 3 power supply. I've had a PlayStation 3 in the past. It died. I was unable and at some point unwilling to fix it. You can see here Sony Computer Entertainment, 12 volts, 23 amps, 5 volts and 600 milliamps. That 5 volts output is not so interesting to us, but the 12 volt is definitely interesting. It works. I've tested it on this side that is narrow, relatively narrow. Here you have the AC connection. Here goes 220 volts. On the back you have two holes inside that this is where the 12 volt output can be taken from. And on this thicker end there's a small connector with several wires. Just like with the computer power supply, you need to short circuit. All the wires are white, but you need to short circuit the ones that are at the extremes. So extreme left and extreme right. Connect them together, keep them short-circuited, and the power supply will turn on when you will plug it into the 220 volt socket. We also have the 5 volt output, but like I said, it's not that interesting. This 12 volt 23 amps is quite interesting to have. So another power supply that can easily be used to power amateur electronics circuits that you create at home, if you don't have a proper power supply. Of course, a proper power supply is recommended and is something that we want to have, There are relatively cheap power supplies on the market that you can just buy. In a later tutorial, I will show you how to create your own power supply, a linear one, because most of them that you can find are switch mode power supplies. In some cases, we don't want switch mode power supplies. We actually want linear ones for having much less noise on the output. Anyways, that's gonna be a separate tutorial. I will show you how to build a very simple linear power supply. Although, like I said in the beginning of this video, there are plenty of English tutorials on the internet and on YouTube on how to build a simple power supply. Anyway, thanks a lot for watching my video. I hope it's somehow useful to you. Maybe you've learned something that you didn't know before. Thanks a lot for watching, and I'll see you next time on the next tutorial. See you!